last two quiz problems are composite solids. So just like we did on the second day of class, I'm going to break this solid down into two shapes I know. So if I look, I see a cylinder in the middle with two hemispheres, so half spheres, and if they have the same diameter, 8.4, so if we were to just put the two hemispheres together, we'd get one sphere. So instead of finding two hemispheres, I'm just going to find the volume of one sphere. So I know my sphere volume formula is 4/3 pi r cubed. And then for the cylinder, which is in the middle, we know the volume of a cylinder is the area of the base. So the base is the circle, pi r squared, times the height. All right, so for the sphere first, the sphere has a diameter of 8.4 millimeters. So divide that by 2 to get the radius. The radius is 4.2 millimeters. So in my calculator, I'm going to plug in 4/3 pi times 4.2 cubed. And I'm just going to write what I get as a decimal. So I'm going to do 4 divided by 3, so that's 4/3, times pi, and then times 4.2 cubed. So I get 310.339. And I know I told us to round to the tenths, but I'm going to at least keep it out to the thousandths until the final answer. And then for the cylinder, pi r squared h. So the radius of the cylinder and the sphere are the same. The radius is still 4.2. The height of the cylinder is the distance between the bases. So if the two bases are this circle and this circle, from here to here is your height. So I'm going to plug into my calculator pi times 4.2 squared times 15.2. All right, so pi times 4.2 squared times 15.2. Let's see, when I do that, I get 842.349 if we round that up. So the volume is approximately 842.349. And then I'm just going to add that to my other volume. So 310.339. So the composite solid that's made up of the two hemispheres in the cylinder, its volume is 1,152.69, because we'll let that 7 round the 8 up. So 0.69 millimeters cubed, because it's a volume, so cubic millimeters. All right, let's look at the very last one, number 6. Number 6, we have a cylinder on top and then a cone on the bottom. So if we find the volume of the cylinder first, we know that it's going to be the area of the base, so pi r squared times the height. We said all cylinders and prisms are area of the base times height. So if I look at this, my diameter is 16 feet, which means my radius of that cylinder is going to be 8 feet. And then the height of that cylinder is 22. So the volume is going to be pi times 8 squared times 22. So I'm just going to plug that in. So pi times 8 squared, which I know is 64, times 22. I get 4,423. So approximately 4,423. And then my decimal is 0.36, and I'll take it out to the thousandths. So 0.362. And again, that's going to be in feet cubed. All right, so that's just the cylinder. For the cone, we know for all cones and pyramids that it's 1/3 the area of the base times the height. So 1/3 pi r squared h. So the base is still a circle and the height. Okay, so for the cone, the radius hasn't changed. So 1/3 times pi. My radius is still 8, so I'm going to have 8 squared. But the height of the cone isn't 22. The height of the cone is just from here to here. So the height of the cone is 6. So I'll multiply that by 6. I'm just going to plug that all into the calculator. So 1/3 times pi times 8 squared times 6. I get 402.124. So my volume is approximately 402.124. And again, that's in feet cubed. So we just add those two volumes together to get our composite volume. We get 4825, and then I'll round that to 0.49. So 4825.49 feet cubed.